Okay, let's take a look at Chapter 6, Linux Server Deployment. Our objectives: identify the types of hardware present in most server systems, describe the configuration of SCSI devices, explain the different levels of RAID and types of RAID configurations, and configure the ZFS file system. Install a Linux server distribution, troubleshoot the Linux server installation process, and access an installed system using System Rescue. Part of this will just be done via the lab, so because I don't have a Linux server set up here, so we'll just talk about concepts and so forth. Now, understanding the server hardware, nearly all standard server hardware is supported by Linux. I bought a server off of eBay for $100. And before I did that, I went out and checked, and because I want to make sure that I could not only install maybe an older version of Windows Server, but also Linux. And it doesn't necessarily support every version, flavor, and so forth. So you have to kind of read a little bit close on it. But Linux is a standard one you see on lists on these different hardware solutions. We got our rack mount servers, a thin form factor used to house server hardware installed in a server rack. And let me change the camera here just briefly. I know it's kind of small, so you can't really see it anyway, but we'll give it a try. Here's what it looks like, and so you can see it's a little bit different than maybe your desktop solutions. Heavy. Those are meant to go into some kind of rack type system, and you screw them in. Sometimes they have special mounts that have to be on them. You got a storage area network, a SAN, and uninterruptible power supply devices may also be contained in server rack. Some of those servers aren't meant to store a huge amount of data. They may have only so many slots to put in for the storage, and so that's why you have a separate piece in some form. And the uninterruptible power supply devices, you don't want your server going down ungracefully. Can corrupt files, they can lose files. So you want some kind of UPS on it of some sort. Doesn't have to last very long. One we had at IFR, it's been a while, but I'm guessing maybe 20 minutes, 30 minutes it would last. And you're sitting there, well, that doesn't have much time. Well, all depends upon what you're doing. At IFR, if the power went out across a plant, nobody could do any work anyway. So our goal was to just shut down the servers in that short period of time. And I think I only got involved that one time. I'm not even sure why I was involved, really. Typically, the networking individuals did that. But I remember there being a time crunch. We had to have it everything shut down within so many minutes. When at that point the UPS would fail. And typically, 20, 30 minutes is plenty of time to bring down, if you have multiple people doing the shutdown, to bring down servers and so forth. Um, Now, if you got a hospital type arrangement where they lose power, but power kicks in certain parts of the hospital for medical necessity, you probably need to have your server remain up and running also. And that may be on its own backup source, or maybe something the hospital has, kind of like a generator type of arrangement. Oh, and those racks, we'll talk more about it later on, but those racks can be open, um, and that's oftentimes a good technique because these devices become quite hot. I remember one time that air conditioning went out in that server room, and it became extremely warm rather quickly. Um, they do have the cabinets for servers, such as a closed cabinet, and I'd say almost every time that's got its own cooling in some sort because you got to keep that cool. Um, Reasons why you might have it enclosed is you do have complete control over the temperature. So if you got your server in a huge room and there's no way for you to keep that temperature of the entire room down at a certain level, maybe a closed cabinet makes sense. If you got a small room, it's probably just as easy to cool the entire small room where the servers are stored. Um, Noise is a factor. These machines can be quite noisy, and so in a closed cabinet, it gets rid of some of the sound from that. Understand the server hardware. Minimum height of rack mount server is 1.75 inches, and you saw the size of that server there, and it's not much. Called a 1U server. 2U server is twice as high as a 1U server. It often contains up to 4 CPUs and 8 hard disks. Rack mount servers rarely exceed 4U. Um, I saw some. That's probably new servers, and these may not be rack mount what I saw, but I routinely go out to purplewave.com, look at auctions and so forth, and they had some kind of server hardware out there where the device was this high. Um, may have been old, may have been a combination of server and um, some other item like switches. I don't know. I didn't explore it that much. I figured it's probably older technology. Not that anything's brand new out there. This shows you an example of a sample server rack. Um, I probably wouldn't design it this way, but um, I suppose it's up to the person. You got your web server top and file server, firewall server, database server, email server, your UPS, your SAN, and then your management station, shared monitor, keyboard, mouse down there, and then rack down below. Reason why I wouldn't probably design it that way is if you're sitting there working, and I'm just visualizing this, you'd have to really kind of crane to see that monitor. Not that you routinely do that much on your server. Once you got it configured, then it's just updates and fixing issues and so forth. Most of the times when I've seen this, they'll have that workstation to the side. So when you're sitting there working on it, you're not having to crouch down and so forth. It's a little bit more luxury than that. Part of those racks also is that there's different types of racks. There's some with just a single leg on each side, so you got two legs on it. Those oftentimes have to be mounted at the ceiling. Um, Then they have some that have the 4 posts. 4 posts are a little bit more stable. You probably still want to mount it to ceiling, though I suppose you get away with not doing it on that in that account. But it's definitely those ones with 2. You can see how those could easily fall over, and easily. If you ever lifted one of those servers, you'd said they're not going anywhere. But if you had a earthquake like we seem to be having, and it's rather a severe one, you don't want your servers falling over and falling on the ground. Now, configuring the server storage, one of the important configuration tasks involves configuring the permanent storage devices that will host the operating system. This involves selecting storage devices, creating partitions, and file systems. Your SCSI hard disk configuration, SCSI small computer system interface, a way to connect multiple peripherals to the system. There's 3 types of SCSI disk configurations: parallel SCSI, serial attached SCSI, and iSCSI. Your parallel SCSI configuration, ribbon cables transmit information between hard disk and SCSI controller. You got a terminator, prevents signals from bouncing back and forth on a connection cable. You got your SCSI ID, uniquely identifies devices attached to a SCSI controller, including target ID, and identifies your priority. And here's a picture of it. This is okay. They're demonstrating you can have your controller card at the end of the looping, or you could have it in the middle. Let's look at the difference between those two. There's common SCSI standards. If you're into hardware, you probably get excited about that. I'm not into hardware, so you can read about that and the speed and so forth. As always, there's a trade-off for everything. I'd like to have the most memory, the fastest computer when I go down to buy one. But truth of the matter is I can only afford so much. And that's what companies have, is they get budgets. They'd like to have the top of the line server. Just go ahead and pick the very bottom one, that has the best speed. But again, that's not practical in the real world. Configuration steps for the parallel. Verify all SCSI components support the same technology. Ensure components are connected properly. Make sure system recognizes hard drives at startup. Now for our serial attached SCSI. Serial attached hard disks connect to SCSI controller via serial cables with small serial connectors. More than 60,000 devices per controller. Configuration steps. Connect hard disk to controller via correct serial cable. Ensure that hard disks are detected by the system or SCSI BIOS. Rest is performed automatically by the controller. And then our iSCSI, the Internet SCSI, uses network cables to transfer data to/from remote hard disks. Our iSCSI initiator, computer connected to remote hard disk. Can be software or hardware. And then target is a remote hard disk contained within a remote network attached device. Configuration settings vary by manufacturer. Must specify configuration settings during Linux installation. Now for our RAID configuration. If you're setting up a server, RAID of some sort is important. Again, there's different levels you can have. Idea behind RAID is, let me give you an example. This has nothing to do with server connection, but we had a database at one place I worked, and had some issues where we lost a week's worth of data. And I don't even remember the reason why the backup wasn't working or what it was exactly. So when it failed, we had to go back a week. We had to go to production floor. We had to tell them that we lost a week's worth of data. We thought they'd be really upset. That's a lot of data to lose, and that they act like it wasn't a big deal. They just entered in. So I was kind of shocked by their attitude. Many database systems have it set up such that when you form a database transaction, it creates a kind of like a rollback record, so that if something goes wrong, you can roll it back to the last good place where the database was. So, for example, and there's different setups on this, so you can't use this as a great example. But if you're buying something on Amazon and you have 10 purchases are made, and it's all of a sudden the database fails. Well, you don't want it to go back to the previous night's record. Then everybody who made any purchases would lose those purchases. You need some kind of redundancy. And besides the redundancy, you need some kind of log of what's occurred. RAID is a server equivalent of that. Your server fails. It has a fault of some sort. Well, do you have some kind of redundancy for the data, or do you lose all data? Now, this is assuming like a fault on the storage medium. Do you lose all your data for that day? You have to send an email to your company saying, "Hey, anything you did today is gone. Please redo it. We're sorry for the inconvenience." Or is there a backup of some sort? And that's the idea behind RAID. Is it's a good backup system, redundancy. Not really backup. I shouldn't say backup. It's more of a, no, it is. I guess it is kind of a backup, real time. Now, RAID, fault tolerant device exhibiting minimum downtime after failure. That's what we talked about. The idea is the user shouldn't even really notice it. If you have a hard disk fail, then they shouldn't have lost any data. They shouldn't even notice it gone down. It kicks over to a backup. RAID stands for Redundant Array of Inexpensive Disks. Inexpensive is kind of the key there. Typical implementation of fault-tolerant disk can be used to speed up access to hard disk, combine several hard drives, storage space, and there's 7 RAID configurations, level 0 to level 6. And again, depending upon how much money you have, is what kind of levels what you choose to use. It's hardware, software, or firmware based, and there's different configurations processed for each type. Now, for our configuration for RAID, we got spanning 2 hard drives seen as 1 volume. RAID level 0, not fault tolerant. Useful when you need a large amount of space and a single volume without fault tolerance. We got disk striping, and individual files divided into sections and saved concurrently on multiple disks. RAID level 0, not fault tolerant, decreases read-write time. So you see, sometimes there's a trade-off in performance. Disk mirroring, 2 identical hard disks. RAID level 1, this is fault tolerant. Unless you have both fail, it's the exact same time. RAID level 2 is no longer used. RAID level 3 is disk striping with a parity bit. Write portions information to different disks, and one of the disks used to store the parity information. Parity bit indicates what data is where. Intermixed on hard drives that contain data can be used to regenerate data if one of the disks fails. And RAID level 4, only a slight variant on RAID 3, offers greater access speed than RAID level 3. 5, replaces RAID 3 and 4. Most common RAID configuration requires a minimum of 3 disks. Parity information is not stored on a separate drive. It's intermixed with data on drives to make up a set. Offers better performance and fault tolerance. And if any drive fails, information on other drives can be used to regenerate the lost information. Now 6 uses 2 sets of parity bits for added fault tolerance, allows up to 2 hard drives to fail simultaneously while remaining fault tolerant. Why might a disk fail? Well, could be it just has a design flaw. If it's a design flaw, probably not 2 disks will fail at the same time. It could be just the age of it. And you might have two pieces of equipment that you bought at the same time, so the age might be about the same, but odds of it failing exactly the same time are almost non-existent. If you have some kind of occurrence, let's say you didn't have some kind of voltage protection, and you had a sharp spike come through. Well, the fact that it destroys one, it may destroy another one at the same time. Then you got a different issue of why you didn't have that protection there. Excuse me. Okay. Now to configure a hardware RAID, to use the RAID setup utility for your specific SCSI or SATA hard disk controller. Once configured, your hardware RAID volumes will automatically appear as standard hard disk volumes to the Linux installation program. To configure a firmware RAID, configure a RAID volume using a RAID setup used utility within the system BIOS. Start the Linux installation and select the firmware RAID volume. We got software RAID. This is configured entirely during the installation process. During the Fedora 20 installation, ensure that multiple disks are present, selected on the screen, select the partitioning strategy, well as I want to review/modify my disk partitions before continuing. Create your partitions to host your Linux file system, select RAID, and choose a level. And then use the MD ADM. I'm guessing multiple disks admin command to manage your software RAID configuration after installation. I've never set up a Linux server, so I'm not going to sit there and tell you I've seen exactly what you're talking about on these. Plan to. That's why I got that server off of eBay. I want to set up a Linux server. I want to do the entire configuration along with a Windows server. So I want to try a couple of different configurations. Okay, this just gives you a screen what they're asking for. Excuse me, grab a drink here. Woke up early this morning worrying about the snow. Couldn't get back to sleep, so I was watching the news to see what they'd say. Okay, ZFS configuration, Zettabyte file system, a high-performance file system and volume management software designed for large-scale Linux systems that need to store data on multiple disks, SANs, and remote systems. Detects and repairs data errors automatically as data is read and written. ZFS protects against problems commonly seen on large systems that write large amounts of data in non-ZFS file systems, including silent data corruption, bit rot, disk firmware bugs, phantom writes, misdirected writes, driver and kernel buffer errors, accidental driver overwrites. Probably if you knew some of the real issues that happen with hardware, anytime you had a document that you put a lot of effort into, you'd probably save multiple copies in multiple mediums, so you wouldn't have lose it. Okay, ZFS supports new storage technologies such as PCIe SSDs and battery-backed RAM disk devices. Caches frequently accessed information in RAM and SSDs to provide ultra-fast performance. Supports nearly all advanced file system features and primarily used on large Linux systems. Also used within small and medium-sized organizations, require flexible volume management for data that is easy to configure. We have something called ZFS pools, groups of physical disks that ZFS can manage. We have ZFS volumes, ZFS managed file systems that are created from ZFS pools. Use the zpool command to create a ZFS pool. Use the list option to view details for your volume. Use the status option to view the status of those disks. Use the ZFS command to manage specific features of the ZFS file system stored within ZFS volumes. Allows you to set directory size quotas and file and directory specific features and performance options. Linux systems, ZFS volumes are mounted by the ZFS system, not via entries within the ZFS table file by default. Add lines ZFS mount volume name to a system startup script. Now, installing a Linux server distribution. Linux server distributions do not have a GUI environment installed by default. Most distributions ship with a set of packages that are commonly used on Linux servers, such as web server, database server, file server, and email server software. Now it says Linux server distribution installation differs from a standard or live Linux installation. No GUI environment is loaded, and installation program often prompts for additional information. Now, there's different reasons why this might occur. Maybe you want to save space. That might be one issue. Although I don't think GUI takes up that much space, in terms of how big drives are anymore. But even more important part is anytime you're opening up or installing a GUI of some sort, you're opening up more ports, more places where it can fail. So things you have to consider. You'd like to have that nice GUI so that you can, easily configure it and so forth. But running everything in, the terminal side where you have the command line is probably preferable for a server. We had a Oracle server that was, I think it was Linux based, either that or Unix, though they're kind of one and the same with the commands and so forth. But it had a GUI to it. And you might say, well, why would you put that on your database? You said GUI just opens up more issues. We wanted to have a user-friendly interface. We didn't want to do everything via command line. That's kind of a pain. And the server was internal. So that database server is just for our internal customers, we can call them. Nobody outside the company would be accessing that server. So that's where we felt comfortable having that. Not that I was asked, but I wasn't in on the decision planning on that. But that's typically the reasons you look at. Is this open to the external world? If it is, you don't want people hacking in, stealing your database information. Okay, you need the following: the host name and IP configuration server, whether to allow for automatic updating, package selection, server service selection configuration, bootloader configuration. Grub, Grand Unified Bootloader is a standard bootloader used on Linux file systems. Oftentimes, maybe you have a mixture of people that help you with this. So maybe somebody will give you part of this information, and you're just configuring the server. So it's not just like necessarily a single person event at a larger company. You might have different parts of your IT that are doing different parts. Now, dealing with the problems, Installation may end up abnormally with a fatal signal 11 error message displayed on the screen. This indicates a segmentation fault in which a program access a certain area of RAM that was not assigned. First, check the RAM for errors by running the memtest86 utility. If no errors are present, then check with the system hardware manufacturer to determine if an updated driver is available for your Linux distribution. Probably your best bet is when you get an error. This kind of gives you guidelines on what to do and so forth, and that's nice. But you probably find a lot of because Linux is very ingrained into our society. So you're going to find a lot of documentation on that. So if you search for Fatal Signal 11, you search for your particular hardware, then you're probably going to get maybe a little bit better idea of where to head than just generically check with your hardware manufacturer. Definitely, if you have a new server, you'd want to check with your hardware manufacturer. If I checked with the people that built this server I bought off of eBay for $100, they'll probably laugh at me. They're not gonna provide me free service. They might charge me, but I bet I can find a lot of information on via Google. If you experience a segmentation fault during installation, and both RAM and device drivers appear functional, assume that some hardware component is faulty. You can sometimes fix segmentation faults by turning off CPU cache memory, increase the number of memory wait states in the BIOS, check for correct voltage values for RAM and CPU in BIOS. You can sometimes fix the segmentation faults by checking for power management conflicts and overclocked CPUs. Now, installation process may fail to place a bootloader on a hard disk properly. Ensure that the root, the slash partition, starts before the 1024th cylinder, the 8 gigabyte mark on most hard disks, or create a partition for the slash boot directory that starts before the 1024th cylinder. Problems may arise if the installation program failed to detect the computer's hardware properly. Check the installation log files after installation. Verify system settings to ensure all hardware was detected with correct values. I think the most challenging part I found whenever I've dealt with any error messages pop up on Linux or Unix is they're not very user-friendly. Not that ones on Windows are very user-friendly, but sometimes error pops up. It's just like it's meaningless. They oftentimes will provide more information in log files because they figure log files, you can go and research it and give you a ton of information. Installation log files are created by the installation program. They record events that occurred during the installation process, including errors. And Fedora stores these files in /var/log/anaconda. Now, to verify your hardware settings, examine the contents of the /proc directory or boot up log files. The /proc directory lists system information made available by Linux kernel, readable only by the root user. To view information that Linux has detected regarding a computer CPU, view the contents of the CPU info file in the /proc directory. To ensure Linux has detected the correct amount of RAM, view the contents of the meminfo file under the proc. To see a list of modules currently inserted in Linux kernel, view the /proc/modules file. If a hardware device is not working, consult a hardware vendor's website to find the name of the kernel module. If the module is not present in the modules file, the driver for that hardware is not loaded into the kernel. Here's your common files in the /proc directory, and I'm not going to sit there and read that to you. But these right here may help you debug what's going on. depending upon the error. To view hardware detected during boot time, use the D message command. Detect, assuming, message command after system startup. To view the system processes that started successfully or unsuccessfully during the boot. View the contents of the var log boot.log file. I wonder if I have access to that without root. Probably do. Var log boot log. Should I bring that up? Claim we're going to get a lot of snow, but I don't know if they're right or not. Probably so small you can't see it, but we'll see. I didn't think I was going to go into this at all today, so I didn't make it. Larger. And oh, guess it is var log messages. And I'm looking at boot.log, I guess. Nano boot.log. Error reading. Permission denied. That's nice. So what can I see log file wise? Boot log I can't see. Excuse me. These are all owned by root. README I can see. that appeared to have permissions on. Some of these are folders. Here's one. dnf.rpm.log nano dnf.rpm.log -201-90205. And that's not too useful. It's unwritable. I know it's read only. So this appears just to be redirecting some messages in here. I was trying to show you that some of these files, the log isn't much help. Last log. I wonder what that is. Looks big. And it's not readable. Okay. It's not executable. I thought it would be an executable. Anyway, guess I'm not going to be able to show you much in terms of the logs. VMware network log. I got rights to that. So VMware network.1.log. You look at this, and again, sometimes logs are extremely challenging to understand what in the world it's saying. In Fedora 20, use the journal ctl-b to view the same information would normally be stored within the log. I wonder if I can do that. Journal ctl-b. Won't let me access the file, but allow me to view it via this utility. See, it gives you a lot of different information. Usable, reserved. So quite a bit of information that it writes out to the log file. You may have to do searches on here to see what specific part that you're dealing with that you need to find the results of. I'm thinking I'm in Nano. There, quit. I said a Q for quit. Okay. This displays entries for each boot process. Therefore, it's important to narrow down the time frame. And if you do a help on that, you'll see all the different commands and options and so forth. System rescue. Small bootable Linux kernel and virtual file system used to fix bootloader problems, file system partition problems, configuration file problems, driver problems. This is available on Linux, a live Linux operating system installation media. You can also select rescue installed systems at Fedora installation welcome screen. System rescue can configure the Linux kernel loaded by the live operating system. Uses the root, this is / file system on the hard disk. Mount the / root file system on your local disk under an empty directory in the live operating system. Do a change root / mnt at the command prompt. Change root command will change the root of the live operating system to the mnt directory. You will have root user access to any commands on your /root file system. Okay, summary. Linux servers typically use far more hardware than desktops. It is usually installed in a rack using a rack mount form factor. And that's just one I showed you even. Parallel SCSI hard drives are uniquely identified by a SCSI ID attached to a controller via terminated cable. SAS SCSI hard drives transformation to hard disks using a serial cable. iSCSI is a SAN technology used to transformation from iSCSI initiators to iSCSI targets across a TCP/IP network. RAID is often used in Linux servers to combine several hard disks into one for speed or fault tolerance. RAID can be implemented by software, hardware, or the system BIOS. And different levels of RAID determine how disks are combined and written to. ZFS members are high performance, that's the big one. Fault tolerant file systems is commonly installed on Linux servers. Linux server distributions do not contain a GUI environment and are often administered remotely, again for security reasons. Wait a minute. Often administered remotely. That depends. I suppose there sometimes are. Um, our Linux servers, you had to actually walk into the server room and work with them there. So whenever you do an administration, then you had to be in that physical room. To administer it remotely means you're opening up a possibility that somebody could hack in and so forth. Not that they couldn't hack in anyway, but when you specifically only have that kind of access from within the room, then that secures it. I was thinking about that. I was watching, not that it's realistic in any sense, but I was watching Mission Impossible. I think last weekend, sometime, and they were talking about they called it the mainframe that they had there at the CIA, I think. And again, I know it's not realistic, but it gives you the idea. The only place you could access that particular mainframe in terms of the information was actually in that room. So I always wished that I had remote access, that I could sit at my my desk and do all that. But again, that's opens up issues. Um, let's see. Unsupported hardware, defective RAM, overclocked CPUs, and improper RAM settings can cause Linux installation to fail. Excuse me. The /proc directory contains information regarding detected hardware, is useful when verifying whether installation was successful. And you can use the bootable operating system found on standard and live installation media to access and repair damaged Linux installation. And that's the end of that chapter. So I'll go ahead and stop the recording here.